Hi, welcome to the session on indexes in Oracle database. In this session, let's see what are indexes and their usage and types of indexes in Oracle database. Now, coming to indexes, uh, index is a database object that can speed up the retrieval of rows by using a pointer data in a table. So this is similar to the index in a book, using which we can easily navigate to different topics based on the page numbers mentioned in the index page. If there is no index page, then you will have to navigate to each page till you reach uh, the page which contains the topic that you are searching for. Similarly, without index, a query will have to search every row in a table to fetch the required data. So if you do not have an index on the column that you are selecting, then full tables can occur, which where the query will search every row in the table. So the index which it provides direct and fast access to rows in a table. And these indexes are used and maintained automatically by the Oracle server. Once it is created, there is no direct activity required by a user. In Oracle, we have different types of indexes such as B-tree index, bitmap, function-based index, and there are some more. But let's look at these indexes in this session. Let's start with the B-tree index, which stands for the balance tree index. So this slide explains about the B-tree index, wherein B-tree index contain two blocks, branch blocks and leaf blocks. And branch blocks, so here, using branch blocks, you will have to navigate to the leaf blocks. You will have to traverse through branch blocks, and you'll have to navigate to leaf blocks, which contains the actual data and then row ID. This is one example where index is created on department ID in department column in department table. Index is created on department ID column in department table, and we have values. The actual values are stored in the leaf block, and the row IDs are available along with the value of the department ID, which is used to access the data from the table. So here, what we are doing is, we are traversing to the root branch. First, we are going to root branch, and then we are going to the next branch, next level branch, and then we are finding the uh, values from the ultimately from the leaf block, and we get the row ID, which is used to retrieve data from the table. And this B-tree index is balanced because all leaf blocks leaf blocks automatically stay at the same depth. So when you look for any value, right, you will have to navigate to the same level of path you have to traverse, and then get to the value that you are looking for. So any value that you are trying to retrieve, you'll have to traverse to the same number of levels, and hence this is called as balanced tree, and the data will be retrieved in the same time, whatever value that you are selecting. Let's look at some example by creating the index, and then let's see the data retrieval using indexes. To look at the query plan, we will have to set the auto trace on. So let us set it on, and then see how data is retrieved. So I'm running a query where I'm selecting all the records from all the columns from the table EMPL, and looking for a particular employee. Now you can see it says table access full. So full table access is happening in this query. Now let's create an index on this table and see the data retrieval. The syntax for creating index is create index name on the table name and the column name. Now index is created. Let's execute the same statement that we have executed previously. Now if you look at the execution plan, you can see it says index range scan and index name is IDX. So here uh, the data retrieval is happening by using index that we have created in the previous statement. Here we have created the index, and then when we try to retrieve data using the particular column, we can see the data retrieval is happening using index, so which is comparatively faster than the full access retrieval. So here we have only 14 records, so it does not matter here, but in case of millions of records, this really makes a difference. Now to see indexes that are created on a particular table, we can write a query. Table name, index name from user underscore indexes, where table name is equal to EMPL. So here we can see the index IDX is available on the table EMPL. So using this query, we can actually see what are the indexes that are created on this particular table. Now coming to bitmap index. In a bitmap index, the database stores a bitmap for each index key. So in a B-tree index, what happens is one index entry points to a single row. Like we have seen here, we can see every single entry points to a single row ID. Whereas in bitmap index, each index key stores pointers to multiple rows. So this is a bit different from B-tree index. And this bitmap index is created basically on low cardinality records columns. That is, the number of distinct values is small compared to the number of total number of rows. For example, if you have there's some column called as gender, so it can contain only two values, male or female. So in that case, bitmap index is very useful since the cardinality is low, and then instead of creating B-tree index, bitmap index creation will make the data retrieval faster. Let's look at the creation syntax. So syntax is create bitmap index and then some name. On table name, and I'm creating it on job. Okay, so for the version that I'm using, bitmap index is not enabled, so we cannot create it here, but this is the syntax that is used for creating bitmap index. So it is create, then we have to specify bitmap. So if we do not specify, the default is B-tree index. So whenever we create an index on a table, the default index that is created is B-tree index. So for bitmap index, we have to specifically mention the keyword bitmap. Now coming to function-based index. A function-based index computes the value of a function or expression involving one or more columns and stores it in an index. So a function-based index, it could be any of these B-tree index or bitmap index. Case function-based indexes, they are very efficient for evaluating statements that contain functions in their main process, and also These indexes are effective only when we use particular function in our query, else they are not used. Let's see example by creating a function-based index. Let's create a function-based index on EMPN. Let's say upper of ename. Now index is created. Let's see how this is effective in when we run a query. So select star from EMPN where upper of ename is equal to Alan. Here we can see index range scan, and this particular index is being used. So when since we are using this function, we can see we have created an index, function based index, and index is coming into picture whenever we are trying to use this function. Let's use another function and see if this particular index is used. So here we can see the full table access scan is happening. So index is not used since the index that we have created is based on the function upper, and we are using lower function here, and hence full table access is happening, which will take more time in in cases where the data is available in millions. Here, since it is very less data, so we will not notice any difference. So this is how a function based index works. Uh, we can also create indexes based on multiple columns. So I can drop the index, and I can create index. So now index is created. We can also see what columns are included in the index from the table, all on IND columns. So here we can see the index name is IDX, and then table EMP ename and EMP employee number. So here we have created a index using multiple columns.